Okay guys, so this is the Asus graphics card Geforce GTX570 that we got at the car boot sale this weekend. I bought three things, so we'll consider this one owes me €12.50. The Creative Sound Blaster Platinum owes me £12.50. Then the little Radeon card owes me £5, so let's consider it that way. So it's clean, it looks nice. We could, I mean, you could say we could just plug this in, but personally, I'd rather have a look to see what condition it's in first, just to be sure that there's nothing we need to know about before we power it up. One thing we need to find is a star key screwdriver, because these are little star keys. It doesn't actually look like this has ever been opened up, as being honest truth, but I certainly want to look if just to check out what condition that the thermal compound's in. Okay, let me find a screwdriver that will fit this. Okay, I've got a suitable screwdriver, the little magnetic one, so we can now start to remove some of these screws. As always, we want a little plastic tub to put them in, so just bear with me while I find something suitable that we can use. Here we go. I have to keep all these parts together. It's so easy to start losing things. Wrong screwdriver. Okay, let's get inside here and let's see what we have. I mean, we've looked at a few graphics cards now if you've been watching the channel, so you should have a very good idea of what's inside here. I would assume I have to remove all the screws. Now let's just skip ahead a little bit. Okay, all I've done, I've just removed most of the screws, that's all. We still have these four to take out. These are normal Phillips type screws. If we have a suitable screwdriver that will fit them. Yeah, that one goes. Doesn't exactly fit, but it works. So we take these out. Oh, it doesn't quite fit right, that one. Let's see if I can find a screwdriver that does. See if this is the right size end. Yeah, maybe. Seems to be like a bit of an odd size screw, these do actually. No. Doesn't want to give it up easily, does it? Let's try this one. Yeah, a bit of pressure on that's done the job. Two more to go, eh? Okay. Does it want to come apart? No. This has some more screws along here as well. Maybe we have to remove those, because it seems to be well held in place. There's nothing moving there. Maybe we need to get these out. Again, they're an awkward size. Screwdriver doesn't really want to fit. Well, this one definitely works best. Can't think of anything interesting to talk about this morning while we're doing this. It's a nice day. Weather, sun's out. Sun is shining. Air conditioning on in the office. Let's skip again while we get these screws out. Well, I did eventually find a screwdriver bit that fits these a little bit better. So we just have a couple more to go now, and then hopefully we can get inside this thing. This certainly looks like it's never been opened, because there's no like marks on any of these screws, yeah? I mean there is now, but there weren't. Come on. I think that's the last one. Oh, okay. Now it comes apart. A bit of dust in here, not a lot. It's quite clean. Can we get down to the circuit board and see what we have underneath here? Let's see now. Yeah, it looks like this bracket effectively holds it in place. Probably a good idea to take this bracket off actually, altogether. So we'll take these off. Probably use just a pair of pliers to do this, otherwise I have to find a little nut driver. Let's see what I have in my box of tools here. Somewhere should be some pliers. Yeah. There we go. This should just do fine, yeah. This one just needs loosening a little bit more. Oh, that is stiff, that one is. It's give it up easily. It's coming now. Give it up. Go. Couple of screws in here. Again, it doesn't fit very well. This one's better. You got to be quite determined to get into this thing. Okay. And one more. It was quite cloudy yesterday actually. Went to the beach down at Amadorus. Beautiful beach, but it wasn't so busy. I mean it was still like 25, 26 degrees, 27, something like that, but it was mostly cloudy. But it was nice. Nice way to spend a Sunday. Okay, can we get this thing to open up? Not easily, is the truth of that. This can only be just stuck onto the GPU. I can't be anything else holding that on there. There's no more screws. Have a look. Oh, missed a few screws. That'll probably have a lot to do with that. So we find the little star one again. A bit smaller than that one. Yeah, that's the one. Yeah, I missed 3 screws up here. Must be like 20 or 30 screws holding this thing together. Just for a GPU. Now, does something happen? This end's coming. Oh yeah, it is. It's gonna come. It's just held together with like the sticky stuff here now, which again tells me this has probably never been opened. Perhaps I should have left it, but you know, I always like to make sure these things, check the condition of them before we do anything else. Looks like this should come off one way or another now. Oh, sod. Come apart. I don't want to bend the board too much, but it's like it's something gripping it here. It looks like this heatsink's possibly keeping it in place. Maybe this is like strapped down to the board by this rubbery thing here, by the looks of it. Maybe that makes me feel I'm not so inclined to get this thing opened up. Well, obviously to fix it we have to. Because it may be a bit troublesome putting it back together. See if we can do anything like this. Let's see if we can make some checks as it is. If so, I have to open it up. So we can see there's some inductor coils down here. There's 4 of them, then there's like 2 spare that don't do anything. I'd say there's never been anything on there. It's surprising because there seems to be no capacitors here, and I would have thought there should be. But I don't think anybody's been in at it, basically. So, yeah, so you can see the inductor coils. And then it looks like there would be a row of capacitors here, which there isn't. There's some capacitors on the input. Okay, 2 channels are not used, but they probably had like 570, 580 Ti or whatever, so with a different GPU required more power. I'm a bit surprised I can't see any capacitors though. That seems a bit strange. But maybe there's lots of ceramic ones under here. And a couple more coils up here. So we can certainly look for any shorts on these, although I don't think we have any. Where's my test meter? Yeah, that's let's have a look. So to ground, I've got one end on ground. 1.1 ohms. 1.1 ohms. We know GPUs read like this. We've seen them before. Interesting, these two are connected on the same rail even though there's no coil there. These ones up here, got good contact on it. Why is that wandering around like that? 9. So those two are probably both on the same rail again. Let's have it from down here. This is where you get the so it's down here, so this is on your PCI, so the N3 power coming in. Next one's ground. I think we also have a 3. I think we have a 3.3 and a 12 here. So the 12's on the end, and they look okay. So there's no shorts on this. These are underneath the GPU. Let's get a bit of focus on this side of the board. These are quite large tantalum capacitors. Perhaps maybe that's why there's no capacitors after those coils. Yeah, 1 ohm, so that's on the 1 ohm, so that's on the same as the other rail where I commented there was no capacitors. So those capacitors are on this supply rail where I said, oh, that's strange, there's no capacitors here. So there's definitely capacitors on that rail, so I've no problem worrying about powering that up. Show you I'm not sure you could see the meter before, so let's have a quick look again. There's the meter, black meter probe onto ground. You see, 1 ohm, 1.1, yeah, 1.1. Set this into a bit more. There we are. See what I'm doing a bit better. So you can see the black probe on ground now. 1.1. All these are reading the same. So this is like a one power rail to the GPU. And the missing, well, there's no coil or anything here. So obviously there must be a version of this card that has like 6 phases on the GPU, and this one has 4. So the fact those capacitors are not there, although it seemed a little bit odd, considering that there's capacitors under here on the same rail. Oh, look, there's more here. Yeah, there's another whole row of them here. So what they've done is they just put capacitors on the back of this. Again, these are on the same rail with 1 ohm, yeah. Turn it upside down, it's now opened up. Like magic. Like magic. Heatsink compound's a bit dry, so we'll replace that. And then I think there's another coil down here now. This will be like the standby supply coming in. We've seen these on these things before. No short on there. 100 odd ohms, that looks reasonable. We can see these a bit more clearly now. 9. Possibly feeding the RAM. Normally the RAM has a bit lower, sorry, a bit higher resistance than that. There's another capacitor in here. 9. That's on the same rail as those. That looks pretty good apart from the dried up compound. So let's get some fresh compound on there, and then let's just let's plug it in and see what it does. Okay, see you soon. Okay, so I've cleaned up the GPU and the heatsink. This actually now quite easily comes apart, by the way. Once that heatsink came out, we can have a look. And there was nothing really holding this together, just one moment. Sorry about that, guys. I had a customer come into the workshop. I had to do a little job for them. So yeah, it's all come apart now. You can see the usual sort of things, thermal pads. There was nothing holding this together other than the dried up thermal paste. These are the coils that we were looking at. So these are the MOSFETs. The driver chip will be over here somewhere. Looks very much like all the other ones we looked at. There's another little regulator up here in the coil. So it's worth looking up here for shorts as well, just to be certain there aren't any. But I think this is pretty much good to just plug in and see if it works now. So it's quite possible this had nothing wrong with it, in which case another bit of a bargain really from the car boot sale. No, it's fine. 208 ohms. Seen those sort of readings before. Yeah, this looks good to go. Okay, so I'll get the test rig out and we'll plug it in and we'll have a look, see what we've got, eh? Okay, see you in a minute. Okay, so this is the our test rig. You've seen this before, I guess, if you watch some of the videos. It's socket 775. Nothing amazing, Core 2 Duo, but it's certainly good enough for testing graphics cards and such like. So we have the Asus GTX570 in there. This is my new post analyzer card. That's the other one I normally use, but let's have a look at the new one. So that's plugged in, we're all connected up. There's a little green light on here, which I guess is telling us that we have standby. Yeah, 3 volt standby, so we know the 3 volt standby is here. That's a nice little thing on this new card. I have the monitor connected on the DVI. I'll just set it to DVI input, and we'll just switch it on and see what happens. It's spinning. Post analyzer's running. And it says there's no graphics card. Okay, it says there's no card present. Just I'll just switch everything off. Let's just try cleaning up the PCI connectors, although to be quite honest they look pretty clean to me. Everything's off now by the way, so it's all the power off including the standby. Find my pencil with a eraser on the end of it. Okay. Just give this a little clean. Let's put you back in again. Missed the slot. Okay, we're in. Power on. Standby on. You can see on the you probably can't see that very well actually because the bench lighting's so bright. Try it again. Yep, it's definitely telling us there's no graphics card present. And then continues to boot. Just pushing down the card a little bit just to see if we can make sure we have a good connection here. Yeah, I'd say there's no card present. Let's just look for some stupid thing like the DVI connector fell out. I've certainly seen cards where it says there's no card when in actual fact it means there's no monitor. So let's just check for that, make sure that isn't the case here. Again, start her up. Nope, saying no card present. And then continues to boot. Just to be certain, there's two DVI connectors on this. So I'm going to put the DVI into the other cable into the other connector. Try that one. Nope, same thing. It's definitely not detecting this card. And the last thing, the card actually has, does it have a HDMI? Yeah, it has a HDMI on. Let's just see if we can try that as well, see if the HDMI gives us anything. If I get the HDMI cable into it. Oh, that's interesting. The HDMI cable doesn't seem to want to fit. Have we got a broken HDMI connector on this? Would that cause it to not detect? Good question. Ah, looks alright. I don't think this would cause it to not detect anyway. Oh, it's not a HDMI. It must be a display port or something. Okay. So yeah, I'm sure that's something else. Display port. Okay, so I think we're going to have to open this up and have a look to see what's going on. Knocking things over. Have a look to see what's going on in here. So yeah, let's do that. Let's get the extension cable on here and put something over the top so we can probe some voltage on this card, and let's see what it's doing. Okay guys, so this is the test rig that we use for graphics cards, and we have a little method of doing this if you've seen some previous videos. First of all, we're going to put an extender card in here, and then this, just a cardboard box cut basically with some holes in it, one over here for the cables to come through, and we can put this over the board, bring the PCIe extender up through here, and then just literally drop that into place. Just get the power supply to come around. Okay, And we now have some space we can work. Here's the graphics card. I've just cleaned up the GPU again, took the thermal compound off it. I still have the fan connected. In fact, no, I'm going to disconnect that actually. I think that's going to be make life easier. So let's disconnect that, and we can connect our graphics card up now, and we can actually come and measure some voltages on this. We need a couple of things. We need the voltmeter, obviously. So where do I put it? There it is. Meter. Set to volts range. And we need initially to get some sort of cooling on here. I don't know if the power rails are running on this. So it's just a little heat sink with the thermal compound pad on it, which is quite handy just for sticking on things like this, and we can just see if they get hot, if there's any power on this or not. I'll just adjust the focus, and now let's see what we can see. So we've got everything ready. So I think the first thing we're going to do is just see if there's any heat in the GPU. This will tell us pretty much if there's any V-core supply going to it. So I'm just going to keep my fingers on top of this, switch the power on, and start the PC. No, it's not detected the card. This is not getting hot, which makes me suspect we've got no power to the GPU, the V-core power. Yeah, that's cold. Okay, let's have a look on the meter. So we'll go to ground, and we'll just go onto these capacitors here. Let's see what we have. Oh yeah, we have 1 volt, 1 volt, 1 volt. Well, that's there. This is still cold. So we have power getting to the GPU. This I think will probably be the power to the RAM. Let's have a look what's up on this one. 12 volts here. 12, yeah, I think it's like a filter coil. This is probably capacitors on the input as well. It's a 16 volt capacitor, so that's on the input. One moment. Is it okay? Yeah. Sorry about that, guys. Somebody at the door. Okay, so yeah, we'll just put this back on again. Let's just fire it up. So it's quite clear we have the V-core supply to the GPU. There, 1 volt. Yeah, that's correct. This supply is probably to the RAM. No, that's the coil on the input coming in. There's 2 supplies here. I'm guessing these are for the RAM. So I'm expecting, well, that's low, 0.127. I'm a bit suspicious of that. That's a bit low. Seems unusually low. There's the one down there. This is like the power coming in for the standby. Yeah, 3.3. So that'll power part of the GPU that replies back. Can't see any other supply rails on. There's a voltage regulator down here. 12 volts on that, seems fine. Yeah, so this one seems low to me. Not sure, but I'll have to see if I can just figure out what that is. But my guess is that's one of the supplies to the GPU and to the RAM. The other thing with this one, I noticed before as well, is the resistance of it is fairly low. This should all be off by now. 9.510 ohms. And if that's a RAM supply, looking at other boards, I'm expecting that to be about 100 ohms. And I don't see anything of that sort of voltage. It's a bit grubby around here. I don't think there's something like just stupid like that messing it up. But let's just clean some of this. It's just dust. It's not anything stuck to it as such. Okay. Okay, switch it on. Back onto voltage ohms. Sorry, back onto volts, not ohms. And let's power it up. Now we still have this low voltage here. I'm not convinced that's right. I'm convinced that's wrong. So we need to try and figure out why we have a low voltage here. Is anything getting hot here? No. So it's not like something's drawing a lot of power. A little bit warm, but not hot. This is still cool. Yeah, they're just tepid, you know. Okay, we need to try and figure out why that voltage is lower than it should, because I'm convinced that it is. And then take it from there. So let's power it off and let's see if we can see where that actually goes to. Okay, so we've got it unplugged again. This was, when I've taken the heatsink off, this is warm, definitely warm, so it's obviously drawing power. I just don't think it's running as such. I mean, the heatsink and panel there obviously were helping because the heatsink was fairly cool. So, where does this go to, this 10 ohms, which I'm very suspicious of this thing? Where does it actually go to? So the meter, let's have a look. So from these coils, yeah, reading 9 ohms. I suspect that's probably going to the GPU, you know, and a good way to find that out. I mean, we could trace from that point to see where it goes, but I think another way is if we have a look around here on some of the capacitors, especially the ones down by the GPU. In fact, that one will do 9 ohms, yeah. So it comes to there, and I suspect that goes somewhere in under here. Let's just zoom in and have a look to see if we can see where that's going. So this is the underside of the GPU. There's no capacitors on the GPU on the top on this one, like we sometimes find, so we can't trace anything there. But I think if we can find that resistance, that 9 ohms is present under here, that'll help us. Let's put the meter where you can see it. There you go. So let's have a look around some of these capacitors here and see if we can find that 9 ohms or thereabouts. It's there. It's there. It's there. So it definitely goes under here. I mean, we can see in quite a lot of places that 9.2 is around here. Do we find that around the RAM as well? So these are your RAM chips, and again, there's nothing to get on this side, but underneath the RAM again, we can see a lot of resistors, yeah, sorry, capacitors, and yeah, it's there as well. Look, that's the other. That might be ground end of that capacitor actually. Yeah, that was the ground end. Yeah, it's there. So that's where it's going to. It's going to the RAM and it's going to the GPU, which makes me think I've either got faulty RAM or a faulty GPU, because I'm sure that resistance is lower. You know, compared with other boards we've looked at, that seems particularly low. Let's see if we power this up, if any of these RAM chips are actually getting warm at all. I mean, like if some are getting warmer than others, that's more what I'm interested in. Rather than if any of them are getting warm, I'm more interested if some are getting warmer than others, yeah? Because that might give us some idea. Okay. So, power's on. Switcher on. We don't need the test meter this time, just need to power it up. Finger was on the GPU now, so let's just move the camera where you can see. Just move the whole thing somewhere where you can see it. I have to zoom out a bit. Give you a better idea. Okay, you can see that now. So yeah, the GPU, there's a little bit of warmth in that, which I'd expect if it's got power on it. So we'll just stick this back on the GPU again. Switch it on and power it up, and now I want to see whether any of these RAM chips warm up. That one's got a bit of warmth in it. Get a bit better focus on that as well, eh? Okay. So this one's definitely warm. I mean, when I say warm, let's get the thermocouple and see. It's not hot. It ain't hot. But it's warm. Obviously this is reading my body temperature, yeah? And I think that's warmer than that. Okay, so I should go on one of these here. 34. And this one feels, some feel warmer than others. Could be my imagination, because it seems to read on the thermocouple, they seem to read about the same. 33, 34, 35. This one definitely warmer than the others, yeah? And that one. These are over where the heatsink is from the CPUs. I'm expecting these to be a bit warmer anyway. Or maybe a bit cooler actually because the fan's blowing from underneath. Yeah. That one. These are getting really, well, you can see on the meter, they're getting warm. So we have two here, definitely getting warmer than the others. Maybe this one as well. I wonder if they're getting warm because something else is warming up, if you see what I mean. And these are quite warm. No, I think that's kind of a red herring. I think what's happening is because there's some warmth in these here, it's like kind of like getting to this side of the board, and obviously not this side of the board. So we sort of see that these RAM chips here are warmer than the others, but I don't think that really tells us anything. As I said, we couldn't see any short. I think it's about 10 ohms anyway. All we have for certain is that the voltage here, sorry, here is like unusually low. I have to say, I think it's probably the GPU. But I'm just trying to think if I can find of any way we can actually prove that a little bit further. So yeah, let's have a think about. I'll have a think about that, and let's see if we can devise some other way to prove where the problem is. Okay, switch it on. Back onto voltage ohms. Sorry, back onto volts, not ohms. And let's power it up. Now we still have this low voltage here. I'm not convinced that's right. I'm convinced that's wrong. So we need to try and figure out why we have a low voltage here. Is anything getting hot here? No. So it's not like something's drawing a lot of power. A little bit warm, but not hot. This is still cool. Yeah, they're just tepid, you know. Okay, we need to try and figure out why that voltage is lower than it should, because I'm convinced that it is. And then take it from there. So let's power it off and let's see if we can see where that actually goes to. Okay, so we've got it unplugged again. This was, when I've taken the heatsink off, this is warm, definitely warm, so it's obviously drawing power. I just don't think it's running as such. I mean, the heatsink and panel there obviously were helping because the heatsink was fairly cool. So, where does this go to, this 10 ohms, which I'm very suspicious of this thing? Where does it actually go to? So the meter, let's have a look. So from these coils, yeah, reading 9 ohms. I suspect that's probably going to the GPU, you know, and a good way to find that out. I mean, we could trace from that point to see where it goes, but I think another way is if we have a look around here on some of the capacitors. especially the ones down by the GPU. In fact, that one will do. 9 ohms, yeah. So it comes to there, and I suspect that goes somewhere in under here. Let's just zoom in and have a look to see if we can see where that's going. So this is the underside of the GPU. There's no capacitors on the GPU on the top on this one, like we sometimes find, so we can't trace anything there. But I think if we can find that resistance, that 9 ohms, is present under here, that'll help us. Let's put the meter where you can see it. There you go. So let's have a look around some of these capacitors here and see if we can find that 9 ohms or thereabouts. It's there. It's there. It's there. So it definitely goes under here. I mean, we can see in quite a lot of places that 9.2 is around here. Do we find that around the RAM as well? So these are your RAM chips, and again, there's nothing to get on this side, but underneath the RAM again, we can see a lot of resistors, yeah? Sorry, capacitors. And yeah, it's there as well, look. That's the other, that might be ground end of that capacitor actually, yeah. That was the ground end. Yeah, it's there. So that's where it's going to. It's going to the RAM and it's going to the GPU, which makes me think I've either got faulty RAM or a faulty GPU, because I'm sure that resistance is lower. You know, compared with other boards we've looked at, that seems particularly low. Let's see if we power this up, if any of these RAM chips are actually getting warm at all. I mean, like if some are getting warmer than others, that's more what I'm interested in. Rather than if any of them are getting warm, I'm more interested if some are getting warmer than others, yeah? Because that might give us some idea. Okay, so power's on, switcher on. We don't need the test meter this time, just need to power it up. Finger was on the GPU now, so let's just move the camera where you can see. Just move the whole thing somewhere where you can see it. I have to zoom out a bit, give you a better idea. Okay, you can see that now. So yeah, the GPU, there's a little bit of warmth in that, which I'd expect if it's got power on it. So we'll just stick this back on the GPU again, switch it on, and power it up. And now I want to see whether any of these RAM chips warm up. That one's got a bit of warmth in it. Let's get a bit of focus on that as well, eh? Okay. So this one's definitely warm. I mean, when I say warm, let's get the thermocouple and see. It's not hot. It ain't hot. But it's warm. Obviously this is reading my body temperature, yeah? And I think that's warmer than that. Okay, so let's go one of these here. 34. And this one feels, some feel warmer than others. Could be my imagination because it seems to read on the thermocouple, they seem to read about the same. 33, 34, 35. This one definitely warmer than the others, yeah? And that one. These are over where the heatsink is from the CPUs. I'm expecting these to be a bit warmer anyway. Or maybe a bit cooler actually because the fan's blowing from underneath. Yeah. That one. These are getting really, well, you can see on the meter, they're getting warm. So we have two here, definitely getting warmer than the others. Maybe this one as well. I wonder if they're getting warm because something else is warming up, if you see what I mean. And these are quite warm. No, I think that's kind of a red herring. I think what's happening is because there's some warmth in these here, it's like kind of like getting to this side of the board. And obviously not this side of the board. So we sort of see that these RAM chips here are warmer than the others, but I don't think that really tells us anything. As I said, we couldn't see any short. I think it reads about 10 ohms anyway. All we have for certain is that the voltage here, sorry, here is like unusually low. I have to say, I think it's probably the GPU. But I'm just trying to think if I can find of any way we can actually prove that a little bit further. So yeah, let's have a think about. I'll have a think about that, and let's see if we can devise some other way to prove where the problem is. So really, the only conclusive thing we have is the fact the voltage here is low and the resistance is low. Nothing in particular is getting warm or hot. But with 10 ohms, you know, I mean, like less than a volt, there's not a lot of current being drawn there. So I think really we probably need to have a look here. First of all, yeah, is the low resistance on which side of the coil? That's a good idea. Is it on the load side or is it on the supply side? Could be a problem with these FETs here, I guess. So I think we'll disconnect us from here and get flat onto the bench again and zoom in so you can see them. We'll have a look to see if we can figure out where the supply rail is generated, you know, what's controlling it. So I've put the test meter where you can see it. It's back on resistance mode. Just check the meter, yeah. And we have these are the two coils with the low resistance. So from here, 9 ohms, yeah, thereabouts. And there's obviously 4 look like MOSFETs here to me that appear to be driving that. So I would assume that from the coil would go to, that's obviously ground, I would think. Yeah, coil goes there, so the MOSFET goes to here. and then I'm expecting the other end of the other one to also go here. We've looked at this circuit before, but let's just get some focus. Let's have a look at this again. We have bit of a reminder. Find a pen. Okay, so a quick reminder, or if you didn't watch the earlier videos, this is what's called a buck regulator, or synchronous buck regulator. So we have 12 volts coming in, yeah, and it goes to a MOSFET like so. This is the gate, this is the drain, this is the source, yeah. And this is a switch, so basically when you put a positive voltage, a pulse on the gate, it turns this on, yeah. But from here we have a coil, which then goes effectively to a capacitor, or some capacitors, grounds, and this goes to your GPU, or in this case possibly the RAM, GPU, wherever it goes, yeah. Okay, and then from here we have another MOSFET. Should draw the symbol a bit better with this, you know. Gate, and this one goes to ground, 0 volts, yeah. And the basic way this circuit's working is as here on a controller, yeah. Control IC, and the controller IC is switching these on and off alternately very rapidly with pulses. And basically, when the top one's turned on, the 12 volts comes through this, which is now a switch, it's closed, and starts to magnetise this coil, and some of the electricity, the power, also charges this capacitor. And after a very short period of time, that one switches off, then this one switches on. And when this one switches on, this is now off. So what happens is, this effectively demagnetises this coil, yeah? It actually acts like a switch. When this is on, the current flows down into the capacitor like that, yeah? Because this one is off. So that's the way the current flows for a very short, you know, like microseconds, yeah. Then this one switches off and this one switches on, and what happens now? Basically, the current continues to flow back through the coil like that because the coil is now magnetised, yeah. And this magnetism needs to collapse, induces voltage into the coil. When it collapses, and the current flows that way. So basically, this capacitor charges up to whatever voltage is controlled by these, and basically it depends on the amount of time this one switched on to the amount of time that's switched on, yeah. So the ratio of how long this is on for how long this is on, whether this is on for 10% of the time of that, or 20% or 30% or whatever, that will control the voltage and the magnetism in this coil and control the voltage in that capacitor, and that's how it works. So what I was just doing, I was looking from the end of the coil to see if I could find 2 MOSFETs it connects to, yeah. Once I've found that, one MOSFET should go to 12 volts and one should go to ground. So that's what I'm actually looking for when I'm on this board. Okay, but on our board it's slightly different from that, so I've turned the paper over. And it's the same, but you can see here we've got 2 coils and 4 MOSFETs. So what we're going to have basically is a circuit like this. So this is your 12 volts. This is one MOSFET. This is your coil. This is to your RAM, GPU, yeah. And then this is your gate, which has got the pulse on it, which switches them on and off. Sorry, off a very bit. This is your gate, and this is your drain, and this is your source, yeah. And then same again as I've just drawn. This will go to 0 volts, and again gate, yeah, and this has pulses on, and these go to your controller. Yeah. Okay, and then basically you'll have the same circuit again, so you'll have just another one the same as this, exactly same as this, I don't even need to draw the whole thing for you this time because you can see how it works. Gate to the other coil. Yeah, so you've got two of them basically, and they're both supplying the same voltage because you both have this 9 or 10 volts on. So these are working in tandem, a bit like this is S4 that's driving the GPU. There's two here supplying power. Yeah, but these gates and these gates will all go to the same controller. Yeah, I would imagine. So all those go to the controller like that. And that's what we have. So let's see if we can see that on this board and see if we can see any short circuits. So basically, we'll go from the top coil, yeah? And we should be able to see, let's imagine that's this one. So we should see that one end of this will go to the coil. That's reading 9.1, so that's not the coil. That's reading just 0. So that goes to the coil, yeah? That's one end of this MOSFET. And this probably be the other one that goes with it. So one of this MOSFET also, yeah. So those 2 points there are connected together and go to the coil. That's this junction here, yeah? Then from the other end of one of these MOSFETs will go to ground, is it this end? Yeah, it is actually this end. And the other end of the other MOSFET will go to 12 volts. We knew there was 12 volts on this coil. We basically said it was some sort of filter. So there's power coming in, yeah? And that's one. And the other one will be the same. So 12 volts coming into this one. Was it this end was ground? Yeah. No, sorry, this end was ground. Yeah. And then these 2 points will connect together and they'll go to the coil. So that's how it is. So we could have a short, or we'll call the 9 volts a short. We could have a low resistance here. We could have a low resistance here or here. Somewhere there's 9 ohms, yeah. And the thing is, where is it? So the first thing we need to figure out, nothing was getting hot more than anything else, and I suspect the fault is caused by one thing, one component, not 8 of them. It could be, but you know, I suspect it's one. So as to where is this 9 ohms? Because these are to an ohm meter, these are 0. So the ohm meter is not going to tell you anything here about this, where it is. Last time, if you watched on one of the videos, we used an ESR meter, yeah, and this allowed us to find which side of the coil the problem was. Because to an ohm meter, the coil is basically 0, yeah. So if I put them both on the same side of the coil, because my meter is reading slightly out, it's 0.1, it's 0.1. You can't see the difference. But to the SR meter, you might be able to see that, where the problem is. I'm on the range 1 to 10 ohms, and I'm hoping that from one side of this coil, let me just take these short wires off, and let me put the wires on off my test meter onto here. I'm hoping this will be able to tell me which side of the coil is the problem. Yeah? Is it on the load or is it on the supply? So if we go to one of these coils on the SR meter, look, it reads about 1.36 ohms, yeah? So we need to go to ground from either side and see if we can see the difference. This side's reading on this 1.27 to ground. This will be the load side, this should read the same. So what's this side reading? 1.43, 1.46. 1.25, 1.26. So we can say the problem's on the load side, which is bad. I was rather hoping it was going to be on the other side. 1.42. That's reading a different resistance, because this is sending an AC signal in at 100 kilohertz, and capacitors will pass AC. So that's why I'm reading a lower resistance with this than I was with the normal DC meter. But definitely the lowest resistance on this side. So that's where the problem is on the load. So in that case then, why is it only giving a very low voltage output? Because it's not a short. Let's say this voltage rail should read like let's say the voltage rail should read 1 volt, yeah? Let's say there should be, somewhere you can see both of us hopefully. Yeah. let's say this supply rail to the RAM and to the GPU should have 1 volt on, because it probably is about 1 volt, and things reading 10 ohms, then to DC it's reading 10 ohms, then the current this would be drawing would be about Ohm's law. This is V equals IR, I equals V over R, so 1 volt over 10 ohms is a tenth, so we should be drawing about a tenth of an amp, 100 milliamps, and this circuit should be quite capable of applying 100 milliamps to give the 1 volt on there, because 10 ohms isn't a short, it's just a lower resistance. So let's have a look to see where this actually comes from. I'll just zoom in on this a little bit again. Okay, that's a good amount of zoom. So we can see now the coils, the MOSFETs, the 2 for each one. This is where the 12 volt was coming in through a filter. This is on the 12 volt rail, which is it's a 16 volt capacitor, so that'll be on the 12 volt rail. But I can't see any controller chip around here. In fact, I can't see any controller chip for the other one either. So I'm guessing they're going to be on the back of here, yeah? So here's our power supply. So somewhere behind here is there's a chip with a hole in it. Let's get the microscope. Oh dear. Oh dear. Well, we found a problem. Or at least we found part of our problem. So this chip's blown. You can quite clearly see it's gone bang. The worrying thing about that is, why has it gone bang? I suspect this has gone bang because of something effectively short, because 10 ohms isn't enough to make this go bang. It can supply more than 100 milliamps, so something must have drawn considerably more power than that at some time. And I don't think the 10 ohms is right. I think it should be something like 100. I have a nasty suspicion we've got a blown GPU here. So yeah, so this is the thing, APW7088, and this is going to be what's driving our supply rail. APW7088, make a note of that one. APW7088. I'm sure this is going to, well, we know what it's going to be. It's going to be like a buck regulator with at least two phases. Let's have a look for it. Let's see what she is. Just set off there. Have a look and see what she is. Do we have a data sheet for that? APW7088 data sheet. It's threatening to give us a data sheet. Oh, Andy's has actually found us a data sheet for this time. That's the one. Two-phase buck PMW, yeah, two-phase buck pulse width modulation controller with integrated MOSFET drivers. There it is. This looks like my circuit I've drawn, doesn't it? Takes a voltage ID, so obviously the GPU can send an ID in here that tells it what voltage it effectively wants, so it can choose its own power supply voltage within certain limits depending on the load on the GPU. Tells a bit about it, what it actually is. There's a pin out. Takes up to 50, yeah, up to 15 volts input. We've got a 12 volt input, we know that. So yeah, that's the chip. And how's it got a hole in it? You do wonder what caused this to blow, because the MOSFETs, I think, were okay. The short effectively was on the other side of the coils, and unless there's like a blown MOSFET here, I'm surprised that's gone bang. So yeah, what do we do with it? Well, first thing to check is, can we even actually get these things? So let's see if this is actually an available part and it's cheap. Let's check that first. APW7088. Let's have a look on AliExpress. Start again, eh? AliExpress. APW7. We can get them. We can get them. 5 for €2.98. 5 for that, well, €4 with the postage, something like that. So we can get bought, and it's not expensive. But why has it gone bang? If it was a short on the output, that would make a lot of sense, but it seems a bit strange to have done that when there isn't actually a short. It's just like a 10 ohms, which, although it's like, you know, a tenth of what it should be if it's 100, it still seems to me, unless like when there's more power, more current flows. Where is it? Yeah. Okay, what I'm going to do with this is I'll take off these 4 MOSFETs and test them. If they test okay, should I replace that chip? This is a difficult one. I don't like this 10 ohm resistance. It's wrong. Even if they test okay, if one of these had been short, I would have said, yeah, that chip's blown. There's your problem. But we can clearly see that the lower resistance is on the other side of this coil. We can just, we can make sure we're not going insane here, but there we are. Let's just get some focus. Ground, MOSFET side, 1.44 ohms, yeah. This side, 1.2 ohms. So the short to ground is definitely on this load side, or this low resistance to ground. I don't think there's any much point going any further with this, even though I can get those parts cheap. I don't think there's any much point going any further with this. So yeah, I'll tell you what, let's post a video. Let's see what some of you guys think. Do you think it's worth changing that controller chip? If it is, it's not going to cost very much. Do you think it's worth taking the MOSFETs off and testing them? It wouldn't cost anything, just a bit of time. Yeah, okay, let's do that, and let's see what the jury says on this one, eh? What does the jury say? Okay guys, see you soon. Well, I was going to leave it there at that point, and then it just occurred to me something, that the fact I'm seeing a lower resistance on this side of the coil might just be because there's a lot of capacitors over here, and my ESR meter effectively is reading that, because it's a short as such, it's like 10 ohms, and that's reading much lower than that on this side. It might just be that what I'm reading, which makes it look like there's a lower resistance from this side, is caused by all the capacitors. And we know there's many capacitors on this rail, we know that. So I think actually it might be a good idea to remove some of these MOSFETs, and I think if we remove the 2 that are on the low side, the 2 that are going to ground, that would give us a better idea, because it doesn't make a lot of sense to me that I've got a blown controller if I haven't got a short circuit, and I ain't got a short circuit, if you see what I mean. I have a low resistance. So let's just look again at which on the low side one's going to ground, and let's remove those and see what we've got. I'll just pause while I do the focus. Okay, so let's once again just remind ourselves which MOSFETs went to ground. I think it wasn't this end. I think this end that goes to coils, so this should read 9 ohms to ground. Yeah, I think it was this end, you know. Yeah, it was these, not that end. Yeah, this end of this one. There's your ground, and there's your ground, yeah? I'm measuring to ground. So let's take these two off the board and have a look to see whether that has any effect on the reading. We don't need this for the moment. So what do we need? We want some flux. There's a couple components right down here, but I'm hoping my trick of actually getting some heat in by effectively putting some leaded solder on the FET will help here. Having said that, there's no doubt a big metal pad underneath these as well, which doesn't help. Let's just put the right tip on the soldering iron. I've got a BC2 on, I want a BC3. We've got a lot of heat into here. Switch that on. So let's try get some leaded solder around these, and then let's see if we can remove these with the hot air without disturbing. It looks like there's a little resistor in here and a couple of other components here. Let's see if we can do that. So first of all, can we get some leaded solder onto the pins? I say because there's a pad underneath these, this probably isn't going to help a lot, but we can have a go. No, that's not helping a lot. I'm not going to put any Captain tape on. I think it's probably better to do this without. We'll get the nozzle on the hot air, the wider one. Let's find the wide nozzle. And I want to try and get quite a bit of heat into this pretty much as quick as I can. Where's my nozzle for my hot air? One moment. Under the plastic tub. Yeah. On the hot air. And let's see if we can lift these without disturbing anything else too near to it. Tweezers I'm going to need. Set of tweezers to pick it up with. Probably easier if I come in from this direction, so I'm going to turn this sideways so I can get my tweezers easily onto the sides of it. Yeah. Hot air. Set to 450. It's full blast basically. And let's start warming this area of the board. See if I can get these things off here. Angle it slightly away from those other components and see if she'll come off. Obviously there's a lot of ground plane in this area, or power plane, so it's making it difficult. Doesn't want to come easily, does it? That does not want to come off there easily. It's coming off the board. And the other one. Headset's falling off. Off the board. Okay, let's just wait till that cools down. I'll put it on pause. Okay, so we've removed these two, and by the way, we didn't dislodge any of the nearby components. We can have a look under the microscope, but I can see that they're all still exactly where they should be. There's some good evidence for you, again, if you doubt that other components will stay in place due to surface tension. I mean, I was directing the air kind of away from these components a little bit, but nothing's moved. So, do we still have 10 ohms from here to ground? Yeah, we do. We still have 9 ohms. We still have 9 ohms. There's now no path to ground on the other side of the coil because the FETs are missing. So, on our little circuit we drew, basically we've removed this one. So there's no longer any path from here to ground, yeah? So, those FETs were not like low resistance or anything stupid like that. They're probably fine. I can test them actually and see if they're good. But that has pretty much really settled the fact that we have 9 ohms on this side, which is the GPU and the RAM, and the chances are we're going to have to change one or the other or both to fix this, even if we change that blown up regulator, which is a bit of a pain. I mean, we could, if we wanted, I guess, remove all the RAM and see if the short's gone. But in my experience, if you got faulty RAM, even if you replace the RAM, it will have damaged the GPU by the fact the RAM was faulty. We will leave it at that, and I will look forward to see what you guys say if you think this one is actually worth us progressing any further with. Okay, guys, over to you.